What's up, guys? Welcome to lesson 3.5, add and subtract like fractions. Let's do it. So here we've got -1/5 minus 4/5. So the beauty of this is we got common denominators, and when we got a negative minus something, a good way to think about this is just like adding a negative. These are both negative terms. So we can just add them like typical addition, and remember that our final sum is simply negative. A minus is always a plus negative, and vice versa. Plus negative is always a minus. So what is 1 plus 4? That gives us 5. And the denominators we don't touch. Those stay consistent. We don't add those. We just got to get common denominators. So this ends up becoming -5/5, but what's any number divided by itself? It's just 1, so we got -1. Let's go on to the next. Here we got 1/9 minus 4 and 4/9. Now, when we are subtracting something like this, I think it's best, you don't necessarily have to do it this way, but I think it's best to convert these both into improper fractions. So 1/9, we're already good to go. We don't need an improper fraction, it's just a fraction. 4 and 4/9, well, let's go ahead and convert this. We got 4 times 9 is 36, plus that 4 gives us 40/9. Whoops, that's supposed to be a 9. All right, now let's see the little subtraction here. What's 1 take away 40? So it's 1 minus 40 is the same as 40 minus 1. It's just we get a negative answer. So 1 minus 40 is -39 over, what do we got? -39/9. Okay, and then we can actually divide both of these, the top and bottom, they're divisible by 3. So this becomes -13/3. If we want to simplify to an improper fraction, how many 3's can we pull out of a 13? We can pull 4 out. So we got -4, and what's left in there after we pull those 4 3's out? 4 3's are 12. So we got -4 and 1/3. Okay, that's it. That's our answer. Next, let's go to this guy, 7a plus 4a over 10. Again, we're just going to add across because our denominators are already the same. What's 7a plus 4a? Well, that's like 7 apples and 4 apples. You're going to get 11 apples over 10. But we do want to write this as as a mixed number. So how many 11s here can we pull out? We can pull, 10s, we can pull out 1. So this ends up becoming 1 and 1/10. And that whatever is in that numerator is just like, we can put it in the numerator, it doesn't matter, or we can put it right here. 1 and 1/10 A's. That's how many A's we have total after this problem. And let me circle this up here too. That -4 and 1/3. All right, quick lesson here. Let's do the last one. We got this whole craziness happening here. Now, the nice thing about addition compared to multiplication is in this case, we don't have to if we don't want to. When we got all negatives, it's nice like this, we don't necessarily even have to convert this to an improper fraction. We can just add the whole numbers and then just add the fractions to the fractions. It's totally fine if we do that. So let's do that. What's -2 plus that? These are all negative, so it's just like a regular addition problem with the result being negative. What's 2 plus 9? That's 11. Plus 6 is 17. There's our whole number part. And then what's 9 plus 9/10 plus 9/10 plus 9/10? We just add all the numerators, keep the denominator the same. That ends up being 27/10. But we can reduce that. How many 10's can we pull out of 27? We can pull 2. So those 2 go in as whole numbers into the 17. We add them up there. So it becomes 19, and we got remaining 7/10. Let me undo that. That looks a little bit like a weird 6. We got 7/10, and this whole thing is negative. Your final answer, -19 and 7/10, and done.